Let's get started. Thank you everyone for joining us today for Intruder's webinar on Mastering Cloud Defense, Insights into Protecting Dynamic Environments. My name is Nikki and I'm part of the product marketing team here at Intruder. Before we jump into it, let me share with you a quick snapshot of what we've got on the agenda for today. We'll cover the common mistakes that expose cloud environments and how attackers use asset discovery to discover your attack surface. Andy's going to share Intruder's tips on how to protect your attack surface. And then we're going to hand over to Joe, who will walk us through the platform and demonstrate how Intruder can help you stay ahead. Before we wrap, we'll use the last 10 minutes for a live Q&A with the team. And we're looking forward to spending this time with you. So a few bits on housekeeping. Throughout the webinar, you can drop any questions that you have in the Zoom Q&A chat function. We'll try and answer any questions or as many questions as we can throughout our time together. If we don't get a chance to get to yours, we will follow up with you directly. Any additional questions that come to you at the end of our session or time together, please do feel free to reach out to us via our chat box on the website or in the portal. And we'll also be sharing a recording of this webinar with anyone who's registered. So look out for this in your inbox tomorrow. So let me introduce you to our team and our speakers for today. First, we have Joe Haig, our Senior Technical Support Specialist, who probably some of you have met before. Joe's part of our amazing customer support team. And we also have our VP of Product, Andy Hornegold, who I'm going to pass you over to right now to get us started. Over to you, Andy.
Thanks, Nikki. Hi, everybody. As Nikki has already mentioned, I'm the VP of Product at Intruder right now. My background is very heavily in the offensive cybersecurity space. So I was the EU Red Team lead at Mandiant. Prior to that, I was the regional assurance lead for the Southeast region for context information security, which is now part of Accenture. And prior to that, I was a senior security consultant at Deloitte, but please don't hold that last one against me. So thanks very much for joining me. And thanks very much for taking the time to listen to me wax lyrical a little bit about cloud security and how to defend in dynamic environments. And there's very few environments that are more dynamic than those cloud environments that people are using these days. So just want to give you a little bit of background about Intruder. Won't go into too much detail, but we're an external attack surface management platform, and we're built from the ground up for vulnerability management. So what that means is vulnerability management is where we started, where we cut our teeth. Our CEO, Chris, he's an ex-security consultant. He worked for some of the largest financial institutions in the world, and he found vulnerability management to be overly complex. And at Intruder, one of our key goals is to make vulnerability management as easy as possible. And as we've grown, one of the key things that we've found is that you can only secure what you know about. So we're trying to help you understand what your external attack surface looks like so that you can then start to feed that information into your vulnerability management process. That whole umbrella is what we term external attack surface management. So what do we really try and prevent at Intruder? So one of the key things we try and focus on is preventing ransomware attacks. So we focus, and one of the key areas that we, I suppose, differentiate ourselves from the competition is that the majority of our user base is within that SMB market. So we do have some larger enterprise customers, but one of the underserviced areas within cybersecurity and specifically external attack surface management is that SMB space. What we're starting to see quite a lot from the threat landscape as it evolves is that ransomware gangs have historically had a really good focus on, enterprise, large customers, large organizations, because there's potentially larger payouts if they successfully ransomware those orgs. But as those larger organizations start to build up their cybersecurity defenses and start to spend a lot more money on cybersecurity, it becomes harder and more difficult for those organizations to really be held to ransom. What we're seeing, and this is echoed by the kind of information that Trend Micro has published within their ransomware spotlight is that Lockbit, which was, and as of November, or actually up until January this year, one of the most successful ransomware gangs on the planet, or with their affiliate structure, they were the ones that compromised the most number of organizations. And you can see that actually the targeting for Lockbit has historically been pretty significant within that SMB market. So around 80% of the organizations and the leaks that they published were for small and medium-sized businesses, and the remaining 19.5, 20% being enterprise customers. One of the interesting things that was mentioned on Risky Biz a couple of weeks ago was that there was a bit of a conversation around, after the healthcare ransomware that happened in the US recently, whether or not ransom payment should be banned at a government level. And it's an interesting conversation, but one of the key things that they took away from that conversation was that if that kind of ban on paying ransoms happened and was enforced, then what we'd see is ransomware gangs start to shift more towards that small and medium-sized business. But that's kind of already what we're seeing. We're already seeing that kind of targeting happen. So one of the questions that you've probably just seen pop up on screen is like, just interested in your thoughts. Like, do you think as an organization, and consider this yourself, whether you think it's possible and right for governments to ban ransom payments after a ransomware has happened? I think it's a pretty divisive topic, but just interested to see what the split is amongst the viewers today. So as these gangs are starting to shift more towards small and medium-sized businesses, and I've specifically called out Lockbit, and people might be thinking, well, you know, how prevalent are Lockbit really? And actually, up until November last year, this data is from November, you can see Lockbit pretty much dwarfed almost every other ransomware gang on the planet. So 2,321 leaks as of middle of November last year, and AlphaV, otherwise known as Black Cat, still only at kind of the 650 mark. So Lockbit was prevalent, it is huge, it was a big problem. One of the cool things that we've seen over the last couple of months is actually that Lockbit was significantly disrupted by a joint task force of 11 different countries who have seriously disrupted their operation. That's awesome to see. More kind of engagement like that from government and from law enforcement can really only be for the better. What we do see though is, yes, ransomware gangs can be disrupted. It doesn't tend to take too long for the people who are involved in those kinds of organizations to either set up again as the same organization with the same organizational structure, but on different infrastructure, or they start to move into those different affiliates or those different organizations. So we've seen people from AlphaV who have moved from previous and older ransomware gangs to become Black Cat and AlphaV. So Lockbit has been a big problem. The disruption is a pretty cool place to be. And one of the ways we see ransomware gangs starting to get into these organizations is by exploiting vulnerabilities that are exposed to the internet. For those of you that are listening, you've probably had to deal with at some point a vulnerability like Citrix Bleed that came out last year. Also the plethora of FortiGate and Fortinet vulnerabilities that we've seen recently, all impacting systems that really are exposed to the internet, and you expect to be exposed to the internet. Citrix as a remote desktop application, allowing you to be able to log into those environments, and FortiGate as a VPN and a concentrator to allow people to connect into those environments. So seeing that kind of exploitation, we can see ransomware does start to exploit those vulnerabilities to gain access to organizations. And this is kind of where external attack surface management sits. So one of the key things we try and do at Intruder is alert you to these kinds of vulnerabilities significantly before an attacker has an opportunity to find them. So what does an attack lifecycle look like for somebody trying to breach an organization? Some of you may be familiar with this, others maybe not. This is pretty much how I ground my thinking when it comes to what an attack looks like. It's called the cyber attack life cycle. Others may have heard of the cyber kill chain. And the idea is that with this life cycle, the earlier you prevent or the earlier you stop a breach in its tracks, so further to the left of this diagram, the cheaper it is for you to recover. The nearer it gets to the right-hand side, the more expensive it becomes. And this is the kind of approach that many targeted attacks take, but also a bunch of opportunistic attacks take as well. So you can see we start off with initial reconnaissance, attackers trying to find information, whether that be specifically against your organization or whether they're finding information about a specific vulnerability across the internet using different tools and techniques and publicly available data that I'll come on to very shortly. They gather a bunch of data that allows them to see where vulnerabilities exist or where the organizations that they want to target are. They then move on to the initial compromise element, which is them exploiting that vulnerability, getting that foothold on a system. They then establish that foothold and reinforce that that foothold that they have by potentially disabling security controls, finding additional information. The blue or the teal bit that you can see, apologies, in the middle is the internal element of an attack lifecycle where they will escalate their privileges on that system. They'll carry out reconnaissance within the network. They'll move laterally through that network and they'll persist within that network. And they'll continue with that cycle until they get to a point that allows them to complete their mission, which is usually either deploying ransomware across an estate or potentially exfiltrating data. Now, external attack surface management aims to prevent the initial stages of this attack lifecycle. So initial reconnaissance and initial compromise. And external attack surface management should give you visibility of what that external attack surface looks like so that you can stay one step ahead of an attacker who has to go through this initial reconnaissance phase and then try and find a vulnerability on that external footprint that they've detected and then exploit it. So that's where external attack surface management sits. IBM recently released their cost of a breach or cost of a data breach report, and what they found was those organizations that have an attack surface management tool set actually ended up paying about $162,000 less in the event of a breach than those without an ASM tool. But that's if a breach happens. EASM, external attack surface management, aims to prevent that breach from happening in the first place. So what does the external attack surface management lifecycle look like for those of us on the blue side, like the good side, rather than what the attackers have to do? So this is the standard lifecycle for external attack surface management. It is discover your assets, you scan and assess those assets, you then prioritize what comes out of that scanning. So whether that be finding open ports and services, vulnerability scanning, you prioritize all of the risk associated with those assets, and then you act. So action doesn't need to be full remediation of vulnerabilities. It can be, does this thing really exist? Should it really exist on the internet? If not, maybe switch it off. You don't have to fully remediate a vulnerability. You should, that should be the end aim, but there's situations where, frankly, it's not possible to remediate an issue. There's plenty of industries where that's the case. So what you need to do is try and mitigate the potential of that vulnerability being exploited. So perhaps you introduce a WAF, perhaps you restrict IPs and access to those endpoints. And then the next stage of the life cycle is validating that your fix or mitigation that you've implemented works. In Intruder's life cycle, that would be rescanning your asset or allowing us to automatically rescan your assets, and we'll remediate those vulnerabilities if we no longer detect them. And then finally, reporting is usually added on the end of this life cycle, but really you're reporting at every point within this life cycle. Now, I don't know about those of you on the call, but this life cycle approach seems relatively basic, and it needs to be. It's meant to be an abstraction and a simplification of all of the difficult process that we have to handle to make sure our organizations are secure. And some of the key things that I find that's kind of difficult to manage or difficult to take in with this life cycle is that it actually starts with discovering assets. But that's only one part of what should really trigger this life cycle. There are a whole bunch of other elements that should trigger this life cycle to start for this process to be followed. And those can be, yes, a new asset exposed, which is great. What happens if one of your existing asset changes? What happens if new endpoints are deployed to an API? What happens if your application changes? What happens if new services are exposed on a specific service, on a specific asset? And then on the other side of that, what happens when a new vulnerability is disclosed? What happens when your vulnerability scanning engines release new checks for those vulnerabilities that are being exploited in the wild? And then also, what happens if exploitation happens using old vulnerabilities? So we see this fairly often. One of the big things that's been shifting over the last couple of years is that threat actors don't need to use 0 days to try and compromise organizations. Actually, what they end up doing is spending time on old vulnerabilities that have already been publicly released and then building exploits for them where they can. And that gives them a reasonable amount of success when it comes to compromising targets. So in that situation, do you want to start a scan again to double check that you don't have that vulnerability, even if it's old and potentially prioritized as a medium risk? Do you want to rescan your external attack surface and reprioritize that vulnerability higher up the ladder? Potentially you do. So that's kind of what the external attack surface management lifecycle looks like. And one of the really interesting things is that you have to follow this lifecycle from start to finish before an attacker starts or finishes those first two phases of the targeted cyber attack lifecycle that I mentioned earlier. So there's quite a lot for us to do before an attacker has to do relatively little. So the two elements that I mentioned were kind of, if I was to group them together, reacting to changes in your attack surface when new things come online and things change within your assets, stuff that's within your control or within your organization's control, at least. And then the next step is reacting to changes in the threat landscape. When new vulnerabilities are released, when new exploitation of old vulnerabilities occurs, it's important that we as defenders react to that and ensure that the risk across our attack surface is as low as possible, or at least below our risk tolerance levels. So you can probably already guess what the common mistakes are from everything I have been over previously. But the common mistakes we see at Intruder are people not understanding what's exposed, that potentially leading to compromise. But in my previous life, when I ran red teams, there was not a single red team I ran where, after presenting to the organization and the blue team, telling them the steps we took to compromise their network, there was not one where I did not hear the phrase, "We didn't know that asset was exposed to the internet," or "We simply didn't know what that asset is," or "That part of the network was dark to us and we had no idea that was there." So understanding what your attack surface looks like, what's exposed to the internet, what can attackers find using publicly available data sources. And then also, that's not a point in time assessment. You can't just take one snapshot and then be done with it. Your attack surface does evolve. And if it's not evolving for whatever reasons, perhaps you have a single asset that's exposed to the internet. If that asset doesn't change, if you're not applying patches to that asset, then potentially what happens is you end up in a situation where you have an unpatched asset exposed to the internet. So making sure you're reacting to those new assets, making sure you're reacting to changes in existing assets, and making sure they're being scanned continuously. The other side of that is the threat landscape changes. So we frequently hear, because my attack surface isn't changing, I don't need to carry out any kind of scanning on a continuous basis. And that's a reasonable line of thinking. Like, a lot of people will follow that logically. My attack surface doesn't change, I don't need to scan continuously. But the threat landscape changes on a daily basis. New vulnerabilities, dozens of them are released every day, and potentially in technologies that you have exposed to the internet. So definitely reacting to new vulnerabilities and to exploitation of old vulnerabilities. Now, that sounds like quite a lot, and I'll cover like some data sources and what you can do to try and get a greater understanding of your attack surface and how the threat landscape is changing. And I'll give you some very simple, quick reference tips that you can use to dig into to manage that yourself. And at the end of this, I'll also hand over to Joe, who can show you how we help empower you to do that at Intruder. So starting off, I'm going to go through some common discovery techniques. These are the kinds of things that attackers use to find your external attack surface. And I'm going to go through this relatively quickly. So if you do have any questions, feel free to fire them into the chat and we'll get to them as quickly as possible. One of the ways that attackers find what you've got exposed to the internet is using IP subnet correlation. Now, this will usually only appeal to people who have an IP address range that they own. So Intruder, like we have our own IP address range. We've bought that from Ripe and we have it published to our scanning ranges. It's what is made up of the allow list within within Intruder if you want to allow us to bypass your web application firewalls. Other kinds of organizations that do have this are the kinds of telecoms providers. We have a few who use Intruder to manage their attack surface. But as an attacker, I can look up who owns what address ranges. I can start to build out a profile of ranges and subnets that are owned by different organizations. One of the tools is Hurricane Electric, like really good tool. It's been around for a while, super useful. Another one is Robtex. Robtex does the same kind of thing, gives you the same sort of details and allows you to dig deeper into the who owns what kinds of assets. And then finally, BGP view. So BGP, Border Gateway Protocol, is the thing that allows you to, essentially stitches different elements of the internet together. So me sat at my computer, need to speak to Google. BGP is the thing that allows the rest of the internet in the middle to work out where to send my packets next. So BGP view constantly updates and gives you a really decent view of what is being published and what is being exposed to the internet. The next step that I'll touch on is certificate monitoring. Certificate monitoring is probably my favorite one because, I don't know why, it's super easy to follow. Every time these days, or more often than not these days, when an engineer creates a certificate or has a certificate signed, that certificate signing process will add the certificate that was created to what are called certificate transparency logs. Certificate transparency logs are essentially a central public repo of data for every TLS certificate that is signed. I say every TLS certificate. It's a large percentage of certificates that are added to certificate transparency logs. And the reason they're added to certificate transparency logs is because browsers like Google Chrome start to reduce the trust in certificates that don't exist within those transparency logs. So you can actually query certificate transparency logs really easily. There's a website, crt.sh, which is really great. You just go to that website, enter the domain that you want to find certificates for, and you'll be able to see a bunch of subdomains and certificates that were signed for that domain. So the example we have here is uber.com, and you can start to see the kind of subdomains that that an attacker can start to poke at. Other tools, you can actually go about and do IP address scanning. I wouldn't recommend this yourself. Like, there are a lot of rules and regulations around scanning the internet, and especially in the UK where Intruder is based, we have the Computer Misuse Act, which makes this a very difficult thing to try and do. So wouldn't recommend you do this, but attackers do scan address space and they do harvest certificate names to try and find domains that they want to compromise. And you don't have to manually go and continuously hit crt.sh to try and find this kind of certificate information, you can actually use tooling like Cert Spotter, which is publicly available on GitHub, and it will give you real-time updates for when your domains are have a certificate signed for them. So another really good tool for identifying what an external attack surface looks like. One thing that we do at Intruder and that done previously during my red team days is internet spidering. So on screen, you can see a screenshot of Burp Suite, and it's possible for us to spider any known domains that we have and try and find additional subdomains that we can try and compromise. It's relatively straightforward. It doesn't do much in the way of, I suppose, malicious traffic, because you are just spidering a site and harvesting any domains that you can find within those pages. One of the big ones that is super important and is probably most widely used, and that maybe many of you on this call will know about, are the likes of internet scan databases. So internet scan databases do scan the internet on a regular cadence, usually between 4 and 7 days. Census is one of them. Census is a great tool. You can go to search.census.io, and then you can search for domains to try and find internet exposed assets. One of the other tools is Zoomeye, which is more modern, or it's a younger tool. The one that I think most people will recognize is probably Shodan. So Shodan is the one that originally sparked a lot of, I suppose, furore, and people still use it today to dig into what's exposed to the internet. And you can start to filter down by specific product types. I want to see all IP addresses that have this specific product exposed to the internet. What's really useful here is, as an attacker, if a new vulnerability comes out in a specific type of technology, take FortiGate, for example, I can come to these internet scan databases and find every exposed FortiGate system that Census, Shodan, Zoomeye have discovered, and I can scan those IPs, or I can fire my exploit at the IPs that come back from those databases. This is one of the differentiators between, I suppose, Intruder and other attack surface management platforms. If you're on our premium tier, we scan your external attack surface every 24 hours. So that should give you up to 7 days earlier warning than the likes of Shodan. So the idea really for Intruder is that we're reducing that window of opportunity for an attacker to compromise your external attack surface. Subdomain brute forcing is another way. So this is really simple. I just send a lot of DNS requests one after another. So if I have a domain, take uber.com, I just have a build a word list and I fire DNS requests at publicly available DNS servers like Google's. And I just query one after another in order. And when I get a response, I save that for later investigation. To do this, you do need a word list to be able to query against. So whatever my subdomain is, and this word list, best DNS word list, is the best DNS word list. So it starts with the likes of www, goes through admin, goes through, and essentially you build a list of most common subdomains, and I can fire that to try and find additional targets for exploitation. Passive DNS databases, they're slightly different to internet scan databases. Passive DNS is what happens when these vendors set up listening points within ISPs, within data centers, and all they do is they snarf a whole load of DNS requests, which are usually unencrypted, and the responses, and then they make those kinds of requests public. They're usually anonymized, so you don't know who made the request, but the response is publicly available. Security Trails is one of the tools that allows you to query passive DNS data sets. So it's a good one to take a look at. Rapid7 have their open data, so the Project Sonar tool set. And then finally, this is Shadow Server, which also has a pretty decent passive DNS query set as well. The final two that I'm going to quickly gloss over: search engine dorking, something that we've probably all tried to do once in a while. In Google, for example, you can use keywords like in URL uber.com. That will give me a list of every URL which includes uber.com, but then I can start to remove the most common ones that I know about. So I can use this -site qualifier and remove www.uber.com, and I can start to find weirder and more interesting subdomains as a result. And the final one I'm going to go through is source code analysis. So these days, a lot of people publish things to GitHub or GitLab and potentially in public repos. And those public repos will often contain URLs or at least subdomains and domain assets that potentially attackers don't know about. So you can go ahead and start to query this across all of GitHub if you like, or you can start to automate the whole process and you can start to query the GitHub API endpoints. You can see in real time as new pushes are made to those repos, and you can start to siphon off that data to react more and more quickly. A lot of these tools you can use yourself to secure yourself. They are used by attackers to try and find external attack surface and get those footholds onto organizations. That was, what does my attack surface look like and how can I find what my attack surface looks like and how it changes? When it comes to the threat landscape tracking side of things, there's 3 places that I will point you. The first one is the NVD. The NVD recently stopped updating a lot of their CVE enrichment process. So for those of you that don't know, a CVE number is what is assigned to a publicly disclosed vulnerability in common off-the-shelf software. And the NVD collates all of those CVEs and then they enrich them with additional information. So they give them CVSS scores, they expand on the description. About a month ago, they stopped doing that, which is a bit of a shame. Risky Biz talked about it recently. But there is still a huge data set there for you to dig into vulnerabilities that are coming out on a daily basis. The next one is the CISA KEV list, so the Cybersecurity and Infrastructure Security Agency based out of the US. The guys over there are doing an incredible job. Like their KEV list is the known exploited vulnerabilities list or the catalog. What's really good is it's super easy to use. It's really searchable. You don't need to pay a lot of money for additional threat intelligence. These are the vulnerabilities that are being exploited right now by threat actors in the wild. And they add to that list and then they remove from that list if that vulnerability is no longer being exploited. So again, a really useful tool for seeing what's being exploited in the wild right now. And then the next step along from that is what's going to be exploited in the next 30 days. And the EPSS rating system is how we do that. So first, the Organization for Security have released EPSS a while back. What it does is it gives you a rating or a percentage likelihood that a vulnerability is going to be exploited in the next 30 days. That's really useful if you want to prioritize specific vulnerabilities that you've got in your backlog that you're trying to fix. Which ones do you need to prioritize first? So that's the EPSS side of things. NVD for what has historically been exploited and what's being exploited or potentially going to be exploited. CISA KEV list for what's being exploited right now. And first EPSS for what is going to be exploited in the next 30 days. So I'm going to sum all of this up in, I suppose, 4 tips. How do you, as an organization, make sure that you're staying on top of that attack surface and staying ahead of attackers? One is start to understand what your attack surface looks like. What we often find is that actually it's a fraction of what is internet exposed. And the more you understand, the more you can start to import into your vulnerability management process. React to changes in that attack surface and the threat landscape. So once you've found that attack surface, don't stop. It is a continuous task that needs to be maintained. Make use of data you've already got. So that can be all of the data that I've just provided in this talk, but also if you have cloud environments, you'll be able to see which assets are exposed to the internet. And finally, automate where you can. So obviously everything I've just talked about, there's a whole lot of information there. If you can automate this, you can make life significantly easier on yourself. And conveniently, I'm going to hand over to Joe in a second to go through that. But I think there's one final point that is a lot harder to do. And kind of from my background, I tend to do it on a daily basis, but I recognize that in a blue team, that's not necessarily all the case. So think like an attacker to prioritize what matters most. So one of the things we've been experimenting with recently is security groups in AWS and all of the nesting within security groups, which makes life really difficult as you look at a security group in AWS, whether this asset is actually exploitable or is exposed to the internet, because I could have 9 nested security groups and one of them within that nesting could be the thing that exposes it to the internet. We make that significantly easier at Intruder by doing internet scanning. So we will scan from the internet to your asset, and we will tell you whether it is possible for us to see what's exposed on your cloud assets. So use the tools and techniques that I've mentioned in this to enable you to think like an attacker and start to empower yourself to hopefully become more secure. Thank you very much for listening to me. I'm going to hand over to Joe now to talk through exactly how you can stay ahead and how Intruder helps you do that. So Joe, over to you.
Thank you so much for all the insightful comments there, Andy. Lots of great stuff. I'm going to take you through the Intruder portal and just to sort of explain how we can help address some of those things there. So I'm going to kick off starting on the dashboard. So this is going to be your overview of all of the assets you've added to the portal. So you can see here some general information such as your threat level and your cyber hygiene score, evaluating how you are currently in terms of threats that are present and how quickly you're remediating those. As well as some information on the checks that we have and we're checking you for. So, as Andy mentioned, that threat landscape is changing very, very commonly. So it's a good place. Sometimes you might want to check, are you being checked for X, Y, Z? Hop in there, have a little look. You can see that list is ever growing. You're also going to see on the right-hand side here, then an activity feed. So that's highlighting the activity that's on your account. So here you can see a network update. You can see some TLS certificate expiries, but this will be populated with any updates as and when we run emerging threat scans and things like that, which I'm going to go into in some more detail in a moment. So let's kick off on the targets page. So this is where you're going to add any of your assets. So you can manually add assets, but as Andy mentioned, sort of automating and things like that, we want it to be as quick and easy as possible. So one of the features we have here at Intruder is CloudBot. So your cloud assets, AWS, GCP, or Azure, you can add those to your accounts through this button here, and you can add an integration for these platforms. You're then going to be able to see all of the internet exposed assets, so externally facing targets on the cloud environment available in this list for you to scan. So multiple options here. You can automatically sync them, which just enables you visibility of those assets as and when new things are spun up. We run a CloudBot sync very regularly, so that's going to then come back and tell you, you've got these new assets or you've spun down some particular assets. So it's giving you visibility over your sort of cloud attack surface in that way. You've also got the option below that one to automatically scan them. So as soon as they're added to the portal, you can then get it to kick off a scan immediately, which then provides you with all the insight you'd need, as well as them being checked, as well as you being aware, you also checked for the vulnerabilities that might be present. And then as well, some more useful features like importing the AWS tags. So if you use those on your environment, it's going to be super helpful here. If I click into any one of these particular assets, I can go to the activity feed and I can see further information on what's happened specific to that asset. So we can see lots of emerging threat scans have run on this target here. I can see that it was deleted and then it was restored at this point. So again, helps you sort of navigate that cloud environment. If you've got lots of things going on there, sort of what asset is this? That sort of information is going to be pretty helpful. Onto the next page, you've got your scans page. So here you can see all of the scans that have happened on your account. So whether that be something that a user, for example, has configured a manual scan to run because they're interested in a particular asset. You have also got the automated scheduled scan feature here on the right-hand side. So that's going to run at regular intervals. So this is weekly, monthly, that sort of thing. That enables you to stay aware of any vulnerabilities that might be present on your assets in that way. We've also got here new service scans. So for those of you on one of our plans, you can basically have a new service scan run as soon as any new ports are open on the target or something else is spun up that might be of interest to you. So when that's available, there could be potentially more vulnerabilities on that target. So this is going to enable you to scan those assets for anything that might be present. You've also here got an emerging threat scan page. So emerging threat scans are scans that run before a full vulnerability scan is run. That basically enables you to find some insights, so some other issues that are high, medium, critical, as you can see here. And they are going to run automatically without you worrying about that. So that enables you to react to anything that might be happening pretty quickly, and you don't have to be online all the time scanning. So this could pop through, and then next time you're online, you're aware of that type of thing. So you can click into that one here, you can go through the assets that have been scanned for it, and you can see these ones have all passed for that particular emerging threat. We've also got here the list of current issues. So you can see there's a issues page here. So it's going to just demonstrate anything that we found throughout our scans. You'll also see, for those of you on the premium plan, for example, there's advisories here. So our security team will do some additional investigation work, basically. And then one example is subdomain takeover. So you can see that here. And then if you need any further information on that, the evidence is present on the right-hand side. So this is enabling you to stay aware of further potential issues in addition to the checks that we are performing automatically through the automated vulnerability scanner. You can also see here a list of the fixed issues. So if you're interested in looking at things that you have remediated, as well as things like snoozed, and all the noise that we're removing, making it as easy as possible for you to navigate. The next page I'm just going to highlight is our network view. So again, very useful feature that enables you to sort of see open ports and services running on all of your assets you've added to the portal. So for example, here I have a target called Gin and Juice Shop. I can click into that. I can view the screenshot. So that's going to enable me to sort of navigate what asset that could be and what particular service is running on that port. And I can scroll through all of the assets, filter them as well on this left-hand side here. So I'm interested in anything that might be live and is on port 443. I can filter that and say, so these targets here, maybe I wasn't aware of that particular port. Super useful way of being aware of that. And then finally, we've got our integrations page. So we do integrate with a large number of platforms, including AWS, GCP, and Azure, like I mentioned before, but also some issue tracking platforms, as well as compliance strata, Vanta, and alerting service now, so Slack and Teams, as well as some other platforms there. But thank you so much for listening through to the demo. I'm going to hand back over, and we're going to go over any questions. So thanks, guys. Hi, Nikki.
Thanks, Joe. Thank you both for that. And Joe, especially thank you for the overview of the platform and walking us through the attack surface management capability. We have time for one quick question. And just while we were going through the platform, Joe, I'm going to actually ask you this one that says, what type of cloud assets do you pull through using CloudBot, if that's okay?
Absolutely. Yes. Great question there. So as I mentioned, so when you add any of those integrations, it's going to enable you to have a CloudBot sync run automatically. And that's going to detect anything that's externally facing. So something that might be an IP address or a domain that you can see from the internet, basically. So anything externally facing is basically what's going to be pulled through with our cloud functionality.
Nice. All right. That's all the time we have for today. Any questions that we have outstanding, because there are a few in the chat, just based on timings, we'll follow up with you directly. But thank you so much for everyone for joining our webinar on cloud security. We will get you a copy of the recording in your inbox tomorrow. So please feel free to watch it back, share it with your team. And remember, you can always get in touch with us via the chat box on our website or the portal. If you are new to Intruder and you're interested in taking the platform for a spin for yourself, please head over to our website and sign up for our free 14-day trial. We've just dropped a link into the chat here in the platform for you. And thank you so much for joining us. We hope to see you again next time. Thank you, everyone.
Thanks, everyone.
Bye.
You guys.